So let's begin with exploring how we can represent fractions. Now, I will admit I am a little biased in how I like to represent my fractions. I think that the way most of us learn to visualize fractions is not the most helpful model. For example, let's take a look here at the fraction 2/7. Now, we can absolutely represent this as 2 of 7 pieces, and I've often seen it where people represent this with a pie or some kind of circle that they divide up. I'm not a huge fan of this model because when I show it to people for the first time, there's a tendency to divide once, twice, 3 times, 4 times, 5 times, 6 times, and then 7 times, which produces a lot of uneven pieces and produces more pieces than we originally intended. In fact, there are 14 pieces in this pie when we only meant to do 7. Now, we could try to compensate for that by drawing from the middle, but it becomes very difficult to estimate how big a 7th is if we're just sketching it out with no other 7ths nearby. So we might try to keep this nice and even and get to 3, and then 4, and then 5, that one's a little big, 6, and then 7, where we've got a huge chunk left over. So that's not exactly what 7 pieces is. So instead, I like to look at using a square. If you take a square, you can estimate how you would divide this into 7 pieces so that you get 1 little sliver, 2 little slivers, 3 little slivers, and we want to make sure that we are getting 7 in here. So by 3, I'm not quite halfway through, which is a good sign, because 4 should put me a little bit beyond half, 5 should put me a little further than that, 6 should put me a little further than that, and in fact, we already have our 7ths just by drawing 6 of these lines. This is something that's referred to as the fence post principle. If you'd like to have a certain number of gaps between your fence posts, then you put in 1 more fence post than you would like there to be the gaps. Now, in the case that you draw yours and they're nice and even but you forgot to have a few, you can always just sketch on 1 more and it'll still look pretty much like a square, but since we already had our 7, I'm going to remove this. So this is what 1/7 is 1 of these 7 slices, 1 brought into 7 parts. So 1 brought into 7 parts. That's why we call it division. We are dividing a figure. So 2/7 would be 2 of these 7th parts. So let's shade in 1 and then shade in 2. That would represent 2 of 7. So 2 divided by 7 can be thought of as 2 of our 7th parts, which is 2 times of 1/7, or 1/7 and another 7th. Let's explore what each of these means. 2 divided by 7 means that we actually started with 2 different squares. So let's see why these are the same. We have 2 different squares, and we'd like to divide them into 7 total pieces. Well, to do that, let's first put them right next to each other. And then let's go through dividing all of these by putting 6 fence posts through them all. So we've got 1 fence post, 2 fence posts, 3 fence posts, 4 fence posts is going to put us a little over the first figure, 5 fence posts, and 6 fence posts. So if we do 2 divided by 7, then we would look for one of the things we have created and notice that it's the same size as our 2 1/7. So 1/7 and another 7th is the same thing as 2 7ths, which is the same thing as 2 divided by 7, which is the same thing as 2 divided by 7. So we're seeing that there's a relationship, a story in all of these symbols. Now, if we'd like to see why it is that this is the same thing as 4 over 14, I'm not going to rely on any kind of rules that I've been taught in school. I'm going to instead just look at it through its story. 4 divided by 14 is something that I could look at as 4 different squares that I split into 14 segments, but that seems difficult to do. I don't want to draw 13 fence posts going all the way down 4 different objects. So instead, I might try to look at it through a different lens, like maybe this one right here, where 2 7ths could be thought of as a 7th and a 7th, so 4 14ths could be thought of as 4 different 14ths. Let's write that down. 4 14ths can be thought of as a 14th plus a 14th plus a 14th plus a 14th, which we can write more simply as just saying that it is 4 of these 14ths. Now I have a whole bunch of pictures over here where I have sevenths. I'm going to erase some of these because I've not found them helpful. Let's take away the circles, and let's take away these two blocks. And let's just look at the simplest model we have. This is a model where I have divided up everything into sevenths. And now I'm curious about dividing it into 14ths. Well, one way of doing this is that I could just take all of the sevenths and I could divide them in half. So let's do that. I'm going to draw a line right down the middle. And that way, if I now count each of those little segments, I have 14 equal segments. So I haven't changed the amount of the square that I am claiming, that I am shading in. And that's why we can look at 2 sevenths as being the same as 4 14ths. Because if this was a tray of brownies, then I would have the same total brownies if I had 2 of 7 pieces out of that tray versus 4 of 14 pieces out of that tray. So we get a relationship in being able to represent these numbers in different ways. The top part, which we will often call the numerator, just simply refers to the quantity. So it's how many of these pieces I get. And if we look at the denominator, the number on the bottom, this is something that refers to the size. Denominator, there we go. The size of these pieces. So now it makes a lot of sense why 2 sevenths is the same as 4 14ths, because in dividing each of these into smaller pieces, we needed more of them in order to have the same amount of total brownie that we were assigned. 2 of 7 pieces would be the same as 4 14ths, because in splitting everything in half, we created twice the number of pieces, but each piece is half the size.